So lesson 1.3, we're going to be talking about piecewise functions. Okay, underline the word piecewise functions in your notes right by example 1. Okay, draw an arrow here. That means we are dealing with more than one function. We're dealing with more than one function at a time. Okay, so as you see here, this p of x, again, what do we know these to be also? If we ever see like f of x or g of x, it's y. Okay, so we can also think of this as y. Okay, we have a piecewise function here because I have one function and I have two functions. So right now we have a total of two functions happening. Okay, over here, label this, these are called intervals. Okay, or you can think these are the rules of the functions. Okay, so on your part A, A is 37 hours. Okay, so you can think of this as, okay, I know x equals 37. So we want to know what the answer is if we had 37 hours. So 37, we're going to ask ourselves which interval it goes in. Okay, so is 37 between 0 and 40, or is it greater than 40? It's between 0 and 40. So we've activated this interval right here. Okay, because it's between 0 and 40, which means, so since it's between 0 and 40 and we chose this interval, which equation are we going to use? 1 or 2? We're going to use this equation here. Okay, so we activated that equation. So doing that, we're going to have 12 times what? What's x? 37. We're just going to plug it in. Yep. So if you need to get a calculator, go up and get one. You should take 12 times 37, which is, anybody? Should get 444. Okay? Now, I want you to try the same concept on part B. Okay, so part B wants 43 hours. So we know we're dealing with x equals 43. Try that one. Real quick, reviewing the function that we're dealing with. How many functions do I have?
2.
I have 2 functions, right? I have 1, 2. So we're dealing with 2 different functions. How do I know which function to use? I'm using the 2 intervals given to us, right? Okay, those are the rules as to what function we can use. So here it tells us 43. A lot of you, just because it's what we just did, you did 12 times 43 at first. Why can I not do that? Because 43 does not fall between 0 and 40. Okay, 43 is greater than 40. So which equation do we have to use? We have to use the second one. So we have 18 times what? 43 minus 240. 18 times 43, I know some of you just have the answer. We get 774 minus 240. What's our final answer here? Say that one more time for me. 534. Thank you. Okay, so there we were just given values, picking the interval that they fall in, which gives us the equation that we have to use. Okay. For like a part C, let's try x equals 40. X equals 40. X equals 40. I know this one was a little tricky because I gave you x equals 40, but do you notice that 40 is in both? So how do we choose? The equal to, right? So if we have less than or equal to or greater than or equal to, okay, remember those little lines underneath there? Those mean equal to, okay? But if we just have the less than or greater than, are those equal to? No, they don't have the equal sign, so not equal to. So which one has equal to? What'd you say? Function 1. So this one is what we would choose for x equals 40. Okay, because it's equal to 40. Okay, so we would take what? How would I solve?
12 times 40 equals 40.
We can take 12 times 40, which equals 480. Good. So now let's look at, I want to look at this one real quick. Not in your notes, so just pay attention up here. In this piecewise function, how many functions do I have?
6.
In this one up here, how many do I have? I have 3 functions, okay? Remember, if you said 6, right idea, but remember these go together. This is one function, 2, 3, okay? They are all one function together. Looking at the graph here, if I was just looking at this, how many functions does that graph have?
3.
How do you know?
There's 3 different colors.
There's 3 different colors and there's 3 different looking graphs, right? What is the parent function graph to this? Do you remember? Like y, correct, it would go through 0, 0, but this is our y equals x. Okay, what would this one be? Y equals x squared, and then again, what about this line? Y equals x. What would a v be? Absolute value of x. Okay, so we can see how many functions there are based on how many different lines we see or how many different graphs we see. Okay, so that's how you read the graphs there. One thing I want to talk about is you see this is a value of 2. You see how 2 has 2 different answers? Does that make sense? So this point right here, that's at 2, 3. And this point right here is at 2, negative 6. Which one is 2 equal to? The blue or the green?
Blue.
Why?
I don't know.
What's the difference between these 2 points right here?
Positive one's negative, one's open, one's closed.
That's what I'm trying to get at. So go ahead and write these notes off to the side of example 3. Okay, off to the side of example 3. If we have a closed circle, that means it is less than or equal to or greater than or equal to. Okay, so again, that means we are equal to. If we have an open circle, okay, so that would be if we were just less than or greater than, which means we are not equal to. Okay, so open circle means we are equal to, closed circle means we are equal to. Open circle means we are not equal to. Okay, so in this function over here, with this, these 2 dots here, which function is 2 equal to? The blue or the green? Which one's it equal to? It's the blue, right? Because we have equal to as the closed circle. Okay, we will look at those again. But graphing. Let's move on to graphing here. So we are just going to do part A. So go ahead and draw yourself an X and Y axis on part A. Okay. First things first, how many functions do we have here? How many different functions are there in that graph? Or in that piecewise? 3 functions. Just make yourself a note. I have 3 functions. So how many different graphs are we going to have? Or how many different lines? We're going to have 3 different lines. Okay. We are going to think of these all separately. So I want to think of this first one. Okay. My interval is -6 to -2. We're going to make an X and Y chart. So go ahead and make an X and Y table. Okay, we need to find points to graph. Okay, we are going to use this interval to tell us what points to use. Okay, so where does that interval start? -6. So -6 is going to be a point. What else is involved in that interval? I agree with -2. Is there stuff in between? Right? There's stuff in between, yes? What's in between?
3, 4,
-5,
-5.
-4, and -3. Okay, those are all our x values that are in this interval here. Does that make sense, how I got those? Okay, how do we find the y value to these? If I have my x values here, how do I find the y values? How can I use this guy?
2x and 5.
Yeah, we're going to use 2x plus 5, okay? Because remember, we know f of x equals y, right? So we know y equals that 2x plus 5. So we're going to take each of these x values and plug them in for our function here. Okay? You do not have to write it out every single time. If you want to plug and chug in your calculator, you can. But this is what's happening. I'm using this function, 2 times negative 6 plus 5. What is 2 times negative 6? Negative 12 plus 5 is? Negative 7. So that is my y value for negative 6. How do I find my y value for negative 5?
Same thing.
What do you mean by the same thing?
Same equation.
I'm going to plug it into the same equation, right? So I'm going to have 2 times what?
2 times negative 5.
That negative 5 plus 5. What's 2 times negative 5?
What?
Negative 10 plus 5 is?
Oh.
Negative 5, yep. So you would do that for each point here. Each point you would do that, okay? To save us a little bit of time, I'm just going to fill in the rest here. So I would get negative 3, negative 1, and 1 if I plugged the rest of those in. What was the whole point of making this XY table, do you think? For what? Because our goal is to graph. Does that help us graph?
Yeah.
That gives us the points, right? So remember, these give us our coordinates. Okay, so now I know your graph does not have all the points. Okay, you can go ahead and go off the graph just a little bit if you need to. Okay, I'm going to go ahead and make a coordinate plane up here so you can double check. So negative 6, negative 7, negative 5, negative 5, negative 4, negative 3, negative 3, negative 1, and negative 2, 1. How do I know if my picture looks like it's supposed to? Think back to what we did for section 1.2. We have this function. What is the parent function to that? What should it look like? If we just have the y equals x, what does that look like? A line, a u, or a v? What did it look like? Looked like a line, right? So we know we graphed this correctly because we know the parent function is a line. Okay, so that is my first graph, and then we just connect the dots. Okay, that was function 1. What do we do for function 2? What do you think we do to find the function 2? Same thing, yep. Don't erase yours. I'm just going to erase mine for space. Okay, so you are going to need to make a new XY table with new points, because now we're on to function 2. So here's my x and my y. We need to decide what values to plug in for x. So remember, where does this interval start? Where does this interval start? Negative 2. Where does it end? 1. We need all the numbers in between.
Negative 1, 0.
Negative 1 and 0. Okay. How do we find the y values to these x values? Plug it in for which one?
2x.
Function 2. Yep, we're going to plug it in. So if I take 2 times negative 2 squared minus 7. What is negative 2 squared? Negative 2 times negative 2. 4. Okay, what's 2 times 4? 8 minus 7 is 1. Yes. Okay. How do I find the rest of them?
Do the same thing.
Do the same thing, yep. Then I would do the same thing. I take 2 times negative 1 squared minus 7. So 2 times 1 minus 7. This would end up giving me a negative 5.
And then
Okay, because this turns into 2 minus 7. So then we do the same thing for 0, right? What's anything times 0?
0.
0, so we're just going to be left with that negative 7. And then if you plugged in that positive 1, you would get back a negative 5. I'm going to ask you this before we graph this. What is this supposed to look like? What is this right here supposed to look like?
Open.
What does this square look like? A U. Yep, this should look like a U. Okay? So now remember, what was the whole point of doing the XY chart? Now you know where to graph. Okay? So go ahead and plot those. -2, 1. Is it okay that they overlap? Yes. -2, 1. -1, -5. 0, -7. And 1, -5. One thing we have to check real quick. Remember when we talked about open and closed circles? Remember when we talked about that? Okay. What are these supposed to be if they're equal to? If they're equal to, is that an open or closed? It's closed, so we're good there. What about these two? Those should be open. However, you see how this overlapped with the other graph? Okay, if they overlap, they can be closed. Okay, but what do we have to do with our, this point right here? When x equals 1, what do we have to do? Is it open or closed? It's open because it is not equal to. So we know this circle right there has to be open. Okay, and then you can go ahead and draw your graph. Did the graph look like what we wanted it to? Yeah, we wanted a U. It turned out to be a U. Okay, we are almost done. What do we have to do now?
Find the last one.
We have to do the last one. Okay, so make yourself a new XY table. Okay, first things first, we got to figure out what values we're plugging in. Okay, so what is my smallest value in that interval? 1. What's my biggest? 3. In the middle? All the numbers in between, we just have 2. So we are going to plug all of those in separately. So I have -4 minus 1, which is -5. -4 minus 2, -6. And then -4 minus 3, -7. Wow, what was the point of that? Coordinates. When we're graphing, are we going to have open or closed circles? We are going to have closed because they're equal to. Yep. So go ahead, plot that for our last graph here. So we have 1, -5. If they overlap, what do we do?
They're closed.
They can close, yep. And then 2 to -6, 3 to -7. And then connect your dots. Are we done?
Okay.
We are done. How do I know I'm done?
Because you have all three.
Because we did all 3, okay? All it asks you to do is graph, okay? We have all 3, we are done. Here is what your piecewise function looks like. To double check, how many functions did we say we should have?
3.
Should have 3. Do we show 3 here?
Yeah.
Yes, we have 3 functions here. Okay, is it okay that the functions are connected?
Yes.
Yes, okay. Since they are, even though they are connected, that doesn't mean they are the same function. Okay, even though they're connected, that does not mean they're the same function. Okay, they are still different. So on example 3, I'm going to ask you a few questions that are very similar to what your quiz is going to look like. Okay, on example 3A, how many functions do we have? How many functions are in that graph? Okay. I have a feeling a lot of us are saying 2 because we think this is one function, right? But does it look like the same function? No. So how many functions do we have here?
3.
We do have 3 functions. Okay. That's all I want to touch base on that one. Okay. What about B? How many functions do we have? We have 3 again. Good. One thing I want to ask, a question that's similar on your quiz, is what is happening at the value of x equals -2? So here's the value x equals -2. What's happening? How can you describe what's happening there?
Two of them are on that.
We have 2 points, right? Or there's 2 functions on that point. What is the difference between the 2 functions, though? One's open, one's closed. So which one, so for the open, do you agree this is like function 1? this line, okay? So for function 1, go ahead and write this down. Function 1 is x equals -2 equal to or not equal to? With this open circle.
Not,
It's not equal to. So function 1, it's not equal. What about function 2? What about function 2? Right here. Is it equal to or not equal to? What'd you say? It is equal to. Yep. So for the value of x equals -2, okay, we know that in the first function, since we have an open circle, it's not equal to. In the second function, we had a closed circle, so we know that is equal. Okay. Try one more. What if I told you to tell me what's happening on x equals 1? Try that with your groups. So do the same idea we did here. Tell me what's happening in one of the functions, what's happening in the other. So on this one, which functions is x equals 1 on out of 1, 2, 3? Reading left to right. It's on 2 and 3. So we have function 2 and we have function 3. What can you tell me about x equals 1 on function 2? It is open, so that means what? Not equal. What about function 3? Because it's closed. Yep, we have an open circle here, closed here. That is it for today.